Hello everyone, today we'll be solving the problem number 105, construct binary tree from the preorder and inorder traversal. By now, we have to know what is preorder and inorder and in which order they work basically, right? So here preorder works in the order node left and right. So I'll just write this one down. So just give me a second, let me come to the first example here. So yeah, preorder and this is in order. Preorder works in the this one, what do we call, node followed by left followed by right, right? So and in order works by this one, left followed by node followed by right, right? So this is the order they both follow. So what the question states here, we are given two arrays. We are given two arrays. Here you can clearly see one is pre-order and another one is in order. We are given two arrays, pre-order and in order, and this one we have to reconstruct and return the original binary tree from these travels. We have to return the original binary tree from these traversals. So each value is unique and both the arrays describe the same tree. Each value is unique and both arrays describe the same tree. See here, pre-order is nothing but node left and right, right? So here node left and right. So 3 9 20 15 7 they have given here, right? So and in order is left node right. So 9 3, then again left we have 15 here. So for 9 we don't have anything, right? So it will be we have to ignore this. 9 3 15 27, right? 15 27, 9 13 15 27. This is 3 9 20 15 7. This is fine. So output that we need to get here is 3 9 normal binary tree, right? So here this one will be 20 and this one here we don't have for at this particular level this is 0, this is 1 and this is 2, right? So we in the level 2 if we have any subchildren and for the left node we don't have any subchildren for 1, in that case we have to give null. In that case we have to give null. So here this will be 3 9 20 null null 15 7, right? So that is the output that we got here. Same goes with the example 2 as well. Same goes with the example 2 as well. See here, example 2 we have pre-order minus 1, in order also we have minus 1. So we have the single digit, so answer will be we can directly give minus 1. When we have only single digit we can just return the same digit, right, as output. So this is fine, I think. So now uh, I hope the question part is completely clear, right? So they have given us wonderful examples just for the sake of understanding that, right? So now let's discuss the approach followed by the complexities and then let's write the code. Let's discuss the approach followed by the complexities and then let's write the code. I'll be considering the first example itself for the approach, this one itself, right? So here first thing is we have pre-order and in order given. We have been given pre-order and in order. So we'll be considering arrays, right? So I'm speaking of the arrays. So first is we will start with the root. Root is always first in the pre-order, right? So root is always first in the pre-order. Means node left and right will be considering in the pre-order, right? So we will start with 3 basically, right? So we will start with 3 here. This is fine. So we will find 3 in order. We will find 3 in order. In order 3 comes second. 3 comes second means this one, left followed by node followed by right. So in we will find 3 in order, nothing but left of it, right? So nothing but left of it here, uh, and 9 is right, and 9 so I mean left of it is 9, sorry, left of it is 9. I mean in order I'm speaking of. Right is 1527. Right is 1527. This one I'm speaking of in order. In the terms of in order traversal I'm speaking of, right? So here right is 1527. Left is 3 followed by 9. Left is 3 followed by 9. This one I'm speaking of. In the terms of in order I'm speaking of, right? First, this one we considered 3 in the this one pre-order traversal, and now we are considering the in order. In the in order left side 3 and 9 comes and 1527 comes this one right side. So this is right, let me write this one as left, right? So the next part is we will recur to left, we will recur for left, sorry, we will recur for left, nothing but we will be going with the recursion for the left side first, right? So we'll be making use of the recursion, or we will recur for left here. So pre-order becomes 9, in order becomes 9, pre-order also becomes 9, and in order also becomes 9. In order also becomes 9, right? Now root will be 9, pre-order will be 9, and root will be basically in order is also 9, so root will be 9. So we don't have any elements for the 9 subchild, this one, right? Left subchildren for 9, left and right left and right subchildren for 9. We don't have any subchildren for 9 basically. So we will recur for left, I mean sorry, we will recurse for right subtree. We don't have anything here, so we will return null here. We have to return null, so we will ignore this one. We will ignore this one because 9 is not having the subchildren, right? So next what we will do, we will recur for the right subtree of 3. We will recur for the right subtree of 3, this part, right one. 3 followed by this one 15 27 or 20 15 7 we have, right? So pre-order becomes here, pre-order becomes 20 20 15 and 7, 20 15 and 7. And in order becomes, in order left followed by node followed by this one. In order, the same thing for the in order becomes 15 27, 15 20 and 7, 15 20 and 7 in order I'm speaking of, right? So root is 20, root is 20 here, root is 20 here, right? Root is 20, right? So left of 20 is 15, right is 7. Right is 7, left of 20 is 15, and right is 7. Here we don't have anything, we don't have the particular level for this at all, so we will ignore this one entirely. Now we will continue recursively slicing pre-order and in order to build the subtrees, right? So now this will be 3 9 20. So this thing we have the level. So at this level, at the second level, we have the numbers 15 and 7. So let me delete this one entirely. So this is chaotic man. Let me delete this one entirely. So we have 3 levels. Now we have 3 levels accordingly with the approach. So this one binary tree indexing starts from 0, right? So this will level also starts from 0. So at the level 2, so we have 15 and 7, we have the values at the level 2, so we don't have the subchildren for 9. At that case we will be displaying null. Just keep this in mind, we will be displaying null at that case, right? So here the output will be 3 9 20 null for null, I'll just represent this one by n, null 15 and 7, 15 and 7. So this is the output that we get when we recursively slice pre-order and in order to build the subtrees, right? So this is the output that we got, right? So the output that we got is 3920, this one, which is same as the output that they have mentioned for the first example within the question, first example in the question. So our approach works absolutely correct, our approach works absolutely correct, right? Our approach works absolutely correct in this case. As we are completely familiar with the approach, let's continue with the complexities part. Let's continue with the complexities part, right? So just give me a second here. So what would be the time complexity here? The time complexity would be big of n. So the time complexity would be big of n because we will visit every node exactly once, and hash map lookup is big of 1. We will visit each node or every node exactly once, and hash map lookup is big of 1. So the time complexity or the overall time complexity would be big of n. So what would be the space complexity here? The space complexity would be big of n as well, because we are or we will be making use of the recursion stack. Accordingly with the approach, we are recurring for the left and right subtrees, right? For the root, so we will be going with the recursion stack, and the we will be making use of the hash map as well, right? Hash map of the in order indices basically. So that is the reason the space complexity would be big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n respectively, right? As we are completely familiar with the complexities part and the approach part, we are good to write the code. Let's start writing the code. Let's start writing the code. Right. So first part here is let's do one thing. So we have the build tree here, right? So let me make use of, so we will be going with the hash map as I have said. So let's make use of the map to store the value. to store the value, nothing but index for first fast lookup in order. We have discussed this one during the complexities part and the approach part as well. By this time we have to know this one, right? So here it will be, just give me a second, 1 second. This will be of map of integer. So as we are going with the hash map key and the value, so this both consists of the integer itself type. So I'll just go with a variable map. This one will be hash map new hash map. This is fine. So the next part here would be int. So this one will be pre-index equals 0. Pre-index equals 0. Right. So here the first thing is we have to build the hash map for in order, right? So accordingly with the approach, we have to build the hash map in for in order basically to quickly find the root index in simple terms, right? So let's do that. Let's go with the iteration part here. This will be int I equals 0, I less than in order dot in order dot length I plus plus. So this will be map dot put of. So we will be going with the basically in order dot length. So we haven't just give me a second here. We haven't so we have the parameters pre-order and in order for this one, right? So basically for the build we have in order and pre-order. So how can I write this one? So I can just write it here, mm, in order of I iterated value of the in order along with its index, nothing but I. So this is fine. Let me come out of this for loop entirely. Let me come out of this one for loop entirely. Next step what we'll do, we have to recursively build the tree using pre-order and in-order bounds accordingly with the approach, right? So we are just articulating the same thing in the form of code what we have discussed in the approach, right? So here we have to recursively build the tree using the pre-order and in-order bounds. So here in this case, before making use of this, so before building the tree, so let me make use of the what do we call, helper method or the helper function build, and let's make use of that helper method or the helper function build within the main function build tree, right? So I'll just go with private tree node. So this one, the name I'll just give build here. The parameter I'll just go with pre-order in start and in end, in order start and in order end in simple terms. So this one will be pre-order int in start. This one will be in end, int in end. So this is fine. So within this method, what I'll do, so let's go with the base case here. No elements on this subtree. No elements on this subtree. Here, when I say no elements on this subtree, I'll just go with the if condition here. So this one, if in start, if it is greater than in end, if it is greater than in end, then we will return null. Then we will return null, right? So this is base case when no elements is present in the subtree. When no elements is present in the subtree, here on this case, so this follows the same condition, right? 9 doesn't have anything. 9 doesn't have the subtree, but at this particular level, at the level 2, we have the elements 15 and 7. But for the node 9, we don't have any elements, right? We don't have any elements. In this case, we have to return null. So that is the base case. If in start is greater than in end, then we have to return null. Nothing but in simple terms, if no elements is present in the particular subtree, then we have to return null, right? So now I hope this is clear why we have got two nulls here, right? This is fine. So the next step would be, so just give me a second here. We have to get the current root from pre-order using the pre-index, right? So let me write in this way. I'll just go with the int root val equals pre-order of pre-index. Let's increment this one. This is fine. Also, we have to create the root node. For creating the root node, I'll just go with the variable root and let me assign this one or assign this one. Let's create the root node. So this will be new tree node of uh, this one root val. So this is fine. So the next step is we have to get the index of the root and in order to divide left and right subtrees, right? As we will be going with a recursion. So we have to get the index of root in order to divide left and right subtrees. So this one will be int. This one will be in index. Let me assign this one too. We have to get the value. So I'll just make use of the get that is provided by the hash map get operation. So I'll just go with root val. So this is fine. Now we have to build the left subtree and we have to build the right subtree. For building the left subtree, so I'll just go with root dot left equals build of preorder. So this one will be in start and this one will be in index minus 1. So this one will be root dot right equals build. This one will be preorder. This one will be preorder. Hmm, preorder. So this one will be in index plus 1. We are going with a recursion, right? So here this one has to be in order and in end. So this is fine, man. So the final step is after building the left and right subtree from the in order left and right section, we have to finally return the root node. We have to finally return the root node. Here in this case, I'll just go with return root, return root. Right. So we are done with the build. We are done with the build helper method or the helper function. So let's make use of the same build helper method within the main method or the main function basically, right? So here main function build tree. So here we just have to recursively build the tree using preorder and inorder bounds as per the approach. So I'll just go with return. So this one will be build. The parameters is preorder. We are building with the building the tree using preorder and inorder bounds, right? So for the preorder it is uh, preorder comma 0 and for the in order it is in order dot length minus 1. So this one in order dot length minus 1. So this is it for the code. We have successfully written the code. So I'll just format the code once. I hope this works, man. I hope this works. I have written this one so weirdly. So I hope this works. Let's see. So we have the compiler identifier accepted where not, oh, I haven't given int here. So line number 15. So let me give int here. So this is of the type int. Okay, identifier accepted. That is the reason it is asking. So we still have the error pre-order. So this has to be small o itself. So let me run this one again. So many typos, man. Yeah, now you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases, man. I hope this works for all the test cases. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So the code works absolutely correct on this case. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.